Hello friends, let's start with the new chapter, determinants. So hope you understand this video. So what is determinant first? What is determinant? Determinant is a scalar value. Scalar value means it has no direction actually. Direction here means in mathematics no dependency or independency of negative or positive symbols. Scalar means that the value is a real number and it can be positive also, it can be negative also. It is not dependent on something, it is independent. Okay, so it is a scalar value and it is of course a real number. Okay, so determinant is first of all a scalar value. It can come in positive also, in negative also. Example -2, 1, 6, etc. And second thing is that this is the explaining this in parts. Okay, so first of all it is a scalar value. Second is what? It is a arrangement in rows and columns. Okay, arrangement in rows and columns. Arrangement in rows and columns. It is often seen arranged, or we can say always seen arranged in rows and columns. Here is a representation of a determinant. Suppose -2, 3, 6 and 4. So this is some sort of arrangement of rows and columns. Here we have 2 rows and 2 columns. So it is also called second order determinant. Okay, and remember one thing, that a determinant has always the number of rows equal to number of columns. Okay, so determinant is also attached or enclosed by 2 vertical lines around it. Okay, so this theory of determinant was given by Cayley, C-A-Y-L-E, Englishman Cayley, in the year 1841. So when he used to explain or analyze the theory of determinants, he used to enclose them in 2 vertical lines. So it is now become a symbolic notation of determinants. It is always enclosed with 2 vertical lines and the number of rows is equal to number of columns. Another important thing here is that the rows are represented by a symbol, that is I. I represents rows. Okay, and J represents columns. So here there are 2 rows and 2 columns. Okay, so now to represent these numbers, first we need to know that these numbers are also called elements of the determinant. Here -2, 3, 6, 4 are elements of the determinant. So we can also write them in this way if we don't want to write any number or any explanation part. Okay, just for explanation we can give it as A1, 1, A1, 2, A2, 1, A2, 2. Now remember these things. Why I have written 1, 1, 1, 2, 2, 1 and 2, 2. Suppose this here is number 2, -2. So it is in first row and first column. So row number is written first here 1 and column number is written in second, it is 1. Okay, so here that is why I have written A1, 1. First we need to write a row number, then we need to write a column number. Okay, so here 3 is in first row and second column. Here this is the reason why I have written 1 and 2. So other things you can understand only why I have written 2, 1. This represents the row, second row, and this represents the column, that is first column and second column here. Okay, so this is not necessary. We can write other variables also. I have written here A. Okay, so another important thing is that determinant has a symbolical notation of one more thing, that is the answer of determinant can be written as D, capital D, or a symbol similar to delta also. That is, if we solve this determinant, we will get D is equal to something, or we can write a symbol similar to delta is equal to answer. Okay, so this is a brief explanation of what is determinant, and it is now we need to know that why are we using determinants. What is the use of determinants? Determinants are used to solve linear equations. Okay, the equations of the form ax plus by is equal to c, like that. Here I can write a2x plus b2y is equal to c2. This type of linear equations we can easily solve. We have various theories on this. Our founder, that is the theory giver, that is the Kelly, has explained many principles and the applications of this. So we'll know that how to solve this in a linear equations. We will have a very much benefit in solving this linear equations through determinants. Okay, we'll discuss it later on. So I've given a brief explanation why we are using determinant. What is the application of determinants? Okay, it is mainly used to solve the linear equations. Okay, linear equations. So let's move forward with the next topic, that is expansion of determinants, or we can say how we will solve determinants. So let's just take a second order determinant first. So second order determinant, let us take here 9, 0, 2, 3. So this is second order determinants. Okay, why you call it second order? Because there are 2 rows and 2 columns. Okay, the number of rows or the number of columns in a determinant are also called the order of the determinant. If you are asked what is the order of a determinant and the question is given, we need to just count the number of rows, or we can count the number of columns. That's the simple reason is that both are equal only in determinants. We have already discussed this. Okay, so this is a second order determinant. How to solve it? We will multiply this diagonal, that is minus 9 and 3. We need to multiply first, minus 9 into 3, and by giving a negative symbol, we'll multiply the other diagonal, that is 0 into 2, and this is the simple calculation of second order determinant. So what is the answer? Minus 27 into 0, it is minus 27 is the answer. So you know that determinant is a scalar value. It is not affected by negative symbol or positive symbol. Anything can come as the answer. Okay, it's basically a real number. So this is how we can solve the second order determinant. Now another important thing we need to discuss here is that the minor of a element of a determinant. How to find the minor of the element of a determinant? So before knowing a minor of an element of a determinant, we need to know first of all what is the second order, or we can say the third order determinant. Second order we have already discussed. The third order of the determinant, 3 order determinant. So 3 order determinant will have 3 rows and 3 columns. The simple explanation here is given, or we can say example minus 2, 0, 3, 4, 9, 2, 3, 0, 2. So this is a 3 order determinant. 3 order determinant because there are 3 rows or 3 columns. So how to find the minor of this element? Determinant, or remember one thing, that the minor of a 3 order determinant is always a 2 order determinant. We will solve here. There are some steps to calculate or find minor. Suppose we need to find the minor of the element minus 2. So step 1 here is we need to exclude that row or column in which the element lies. Exclude, or we can say eliminate, the row and column in which the element lie. Here minus 2 is that element of which we need to find the minor. So we'll exclude here this row, this column and this row. This is the first step to find the determinant. Now second step is what? Second step is what? We have got now 4 elements 9, 2, 0 and 2. So we'll write this element here 9, 2, 0, 2 within the vertical lines of determinants. We need to solve this now, and hence this will be the determinant. We know how to solve a second order determinant. We have already discussed here. We need to just multiply the diagonals with a symbol of negative symbol. So here, what is the minor of the element -2? It will be 18 minus 0, that is 18 will be the answer. So what is the minor of the element -2? It is 18. Okay. So this is the way how to calculate the minor of an element. In this way, simply we can find minor of the element 0. Also, we will exclude this column and this row, and find and the rest 4 elements will be put up in a determinant, and hence solve a determinant. So we have already concluded that the minor of a 3 order determinant is always a 2 order determinant. By solving this second order determinant, we'll find the minor of a element. Okay. So let's go to another topic, that is cofactor of a determinant. So let us take a determinant here. 6, 0, 2, 3, 4, 9, -2, 1, 0. So this is a 3 order determinant. We need to find now the cofactors of the elements of the determinant. So for finding cofactors of the elements of the determinant, we need to find the minor of the element. Step 1, find minor. Find minor. Find minor of that element. Of that element, say I calculate of A1, 2. That is, we are calculating of 0 because it is in row 1 and column 2. That is, I have written here 1, 2, A1, 2. Okay. So first step is what? We need to find the minor of that element. How to find the how to find the minor here? We will exclude that column and that row, and the remaining numbers you need to write in a determinant. Now find, or we can say solve this determinant. Answer will be 0 minus 18. That is 18 is the answer. Now here we have calculated the minor of the element. Now how to calculate the cofactor of that element? Step 2, cofactor of element 0 is equal to -1, and to the power of row, it is I, plus columns, that is Z, and this is multiplied by a minor of the element. Minor of the element, say M1, 2. So this is the formula to calculate the cofactor of that element. So simple formula here is -1, add up the columns and the rows in which of which you want to find the minor of, that is here M1, 2, that is I here is 1, column, that is J here is 2. So -1 to the power of 1 plus 2 into minor of the element. We have already calculated the minor, that is here 18. So -1 to the power of 3 into 18, that is -18 is the cofactor of that element. -18 is the cofactor of that element. In this way we can calculate the cofactor by using the minor of the element. So for solving the cofactor, we must be very clear with the minor of the element. So let us do one more sum of a cofactor and this time we will take a second order determinant. say the question is 0, 2, 9, 4. This is the second order determinant. We need to find the minor and the cofactor. Minor not, we will find the cofactor. Okay, cofactor of 2 and 9, say we need to calculate. Okay, cofactor of 2 and 9 we need to calculate. So let us do it of 2. Cofactor of 2 is equal to, we will exclude the row and column. So what is the number in the determinant? That is here 9. 9 is the number. We have excluded the column and the row respectively, so number here is 9. We will write that number. Now to find the cofactor, we will multiply by -1 to the power of the rows and the columns. So where does number 2 lies? It lies in the A1, 2. So we will add A1 plus 2, and the symbol here is multiply between them. Okay, so -1 to the power of 3 into 9, that is -9 is a cofactor of 2. So similarly we can do a cofactor of 9 also. Cofactor of 9 here is -1 to the power of here 2 and 1. Okay, here 2 plus 1, because second row and first column, multiplied by what is the remaining number. We'll exclude this column and exclude this row. The number left is 2. So we'll solve this. Again we will get minus. So let's straight move to the property of the determinant, the various properties of determinants. There are total 7 properties of determinants. Let us start now with the first property. If all the elements of any row or column is 0, the value of the determinant is 0. It's very simple property of determinant. If any row or any column is 0, here the third row is 0, all the elements must be 0, then only the value of the determinant is 0. Or we can say here symbolically d is equal to 0 or delta is equal to 0. Okay, symbolically we can write in this way. So we have already discussed the first property. Hope it is clear. It is very simple. If any row or any column is 0, then the answer will be 0. But the thing is that all the elements of a particular row or a column must be 0, then only the answer is 0. So the second property, the value of the determinants remains same if the rows are exchanged with the column. It is very simple. Here we have taken an example also. Suppose this is a determinant 3 or a determinant. So meaning of this property is that if we replace this row with a column, all these rows with column, then the value of the determinant will not change. Here we have done what? Simply we have exchanged these rows into columns and columns into rows, and the answer of the determinant give us same result. Okay, here 3, 4, 9 was a row here and it has become a column here. See, 3, 0, -3, 0, 2 was a row here and it has become a second column here, and 9, 8, 5 was the third row which has become the third column here. But the answer of the determinant, that is delta, is not affected. This is the important property of a determinant. Okay, so we can use this in solving various problems of the equations. Okay, in the exercise part we need to apply this type of properties to solve the determinants. Now third property of the determinant is that if any two rows or columns are interchanged, then also the determinant is same. If any two rows or columns are interchanged, then also the determinant is same, but they are affected by negative sign. Only difference is what? The negative sign. So meaning of this point is what? Of this property is what? If we say this is a row 5, 0, -1, this is a row, and this is another row, say 2, 9, 4. If we exchange this, 2, 9, 4 will become the first row, 5, 0, -1 will become the second row. Then the difference in the answer is that difference in the determinant is that it will be affected by the negative symbol. See here, it is affected by negative symbol if we have exchanged. Here what we have exchanged? We have exchanged the second column with the third column, and the answer is affected simply by minus symbol in the determinant. So the determinant is same, but it is affected by the negative symbol. If here comes here minus, if the answer here is 2, here it will be -2. this type of relation is there between the determinants. If we exchange the any row or any column, here I have explained only one row and one column. If any row and any column is exchanged, of course they must be 2, all we cannot exchange at one time. Okay, suppose 2 3 4 is replaced by -1 4 2. If these two are also exchanged, then also the determinant will come, the relation between the determinant will be just of the negative symbol. Okay, but the determinant will remain same. So this is the third property of determinant. So the fourth property of the determinant is actually an important one. So let's read this. If each element of a row or column is multiplied by a non-zero real number, say k, then the value of the new determinant is k times the original determinant. Yes, here we have taken a determinant 2 minus 1 4 9 6 1 3 8 0, and we have taken and we are multiplying here with a number 2. It is a real number. We are multiplying this number 2, and we need to write a note here that this 2 is multiplied with which row or which column. Answer, we need to write this here. 2 is multiplied with the third column. So then so this new determinant changes into 6 16, that is 2 into 3 6, 2 into 8 16, and 2 into 0 0. So this we have multiplied this third column with the number 2, but the answer what this come is say delta dash, and answer here come say delta, that is D. So the answer is what, this determinant is equal to k times the original determinant. This is actually important property of the determinant. We can multiply any real number with any rows or the columns. Of course, all the elements of a particular row and a particular column must be multiplied with that number. Okay, and it can be any number. Okay, this is a very important application of determinants. Okay, and similarly we can, the corollary property is that we can take common also here. Suppose here it is suppose 2 4 and 6 are there, then we can take here 2 common also, then also the determinant will be the k times or the k times the original determinant. Okay, so let us move to the fifth property of the determinant. It is an easy property of determinant. If any two rows or columns are identical, then the value of the determinant is 0. Yes, here in two rows or two columns, say here two rows are similar, so the answer is 0, that is determinant is 0. Here 2 2 1 2 2 1, this means what, here two rows are common, that is why the answer is 0. Yeah. If you find any question where two rows or any two columns are similar, all the elements are similar, then the answer is 0. Okay, it is very simple property of determinant. It is the fifth property of determinant. We need to learn this determinant symbol in a very symbolic manner. So learn this property in a serial wise manner, so we can write in a answer that property 5 simply if the time is less. Otherwise we should write a whole line also, then it is very beneficial. So the sixth property of determinant here is, if each element of the row or a column of a determinant is expressed as the sum of the two or more terms, then the determinant may be written as the sum of two or more determinants. Okay, so here we have a lookout, take a brief lookout of the property, and let us explain this with a example. Okay, so take a determinant, say 8 24 36 10 14 16 and 6 12 0. So we need to express any row or column in terms of two or more additional terms. Okay, so similarly we can write here, suppose 10, we can write here 5 plus 5, 14, 8 plus 6 in a sum of two numbers or sum of three numbers also in some cases. Okay, if we can represent a number in as a sum of two or more numbers, then the determinant will be in such a way. Okay, suppose here 10 we have divided into 5 plus 5, 14, 8 plus 6, 16, 14 plus 2, any number which is the if we sum of, we get this number. Okay, if we express this determinant as this determinant, then by analyzing this we will get a determinant. Okay, that is a 8 5 6. We will first write this number 24 8 and 12. We will in the second column we will write this number, and 36 14 0 we will write this in 36 14, this is 14, 36 14 0 we will write in this number. And the reason why you have written the plus symbol, this plus symbol comes here and it will be subdivided into two determinants, and we need to separately find the determinants of the two and add up. We can and then we can find the final determinant or the final answer of the question. Okay, so this formula is simply what we are dividing a determinant into 2 or 3 determinants and then solving it and then finding the answer. Okay, it's quite a lengthy process also, but these properties are useful in solving determinants. Okay, so hope you have understood the 6 property determinants. We have just expressed the second row as a sum of two numbers, okay, and then subdivided it and then solved, and then the answer comes. Okay, so let us move to the 7th property, and it's often said the most powerful property of determinants. Okay, the most important property of determinant is property number 7. Okay, if each element of a row or a column is added with other rows or columns or subtracted from the same, then the value of the determinant is same. So we have taken an example of a determinant. Okay, this is the determinant, and how we have simplified this, have a look out at this. Okay, we have added that is row 1, this is the row 1, this row 1 we have changed into row 1 plus row 3. This is the thing we have done in this example. We have added row 1 and row 3. We have added row 1 and row 3. Okay, so so the row 1 now changes to 2 plus 0, 9 plus 2, 3 plus 5. However, the other two rows remains unchanged. This is the most important thing. Other things remains unchanged, and this type of things we can do with any row and any column. Suppose we want to change R1. I'm taking another example now, forget this. Okay, suppose suppose there is a determinant and we need to change row 1. So row 1 can be changed into 3 into row 1 or 2 into row 3. In this way also we can do. Similarly, we can minus also, that is 3. Suppose 3 R1 we can find and subtract this with 5 R3. Anything we can add or anything we can subtract, and then simplify it into a new determinant and solve this. And why you are using this type of property number 7 is why it is called the powerful property, because it simplifies the determinant in a very easy way by adding or by subtracting. Okay, it simplifies determinant, and the basic aim to solve a determinant is to bring 2 zeros. Of course, if there are 3 zeros, the answer will be 0, as discussed in property 1. But if we can bring 2 zeros, then the calculation becomes easier. So every property of determinant is of the aim to make the zeros, maximum number of zeros, that is 2 zeros they want to find, and if there is 3, the answer will be 0. Okay, so here we can end up with the discussion of the properties of the determinant.